And good morning, everybody. Here are your notes for IXL.com, Algebra 1, Module AA.1, and it's going to be looking for the greatest common factor of monomials. And before we get into factoring monomials, let's just talk about what a greatest common factor is. A greatest common factor is going to be all the factors that the monomials have in common. So let's just go look at a few numbers to start and see what it means to be a greatest common factor. And let's just think of the numbers, let's say 20 and 30. And if we look at all the prime factors that make up the number 20, so we know 20 would be 2 times 10. Factors are just quantities that when you multiply them together, they produce a particular product that you're looking for. So in this case, the product we'd be looking for is the number 20. And we know 2 times 10 makes 20. And the 10, we know we could break that down into smaller factors. So that would be 2 times 5. So if we wanted to write the prime factorization of 20, it's going to be 2 times 2 times 5. So that's the smallest factorized representation of the number 20. So 2 times 2 times 5 should make 20. And if we break down the 30, we can get 3 times 10, and then 2 times 5. So we know that 2 times 3 times 5 is a factorization of the number 30. So if someone were to ask what is the greatest common factor, so if they want the greatest common factor, it's going to be all the factors that are present in both numbers. So what do they have in common, basically? So they have a 2 in common. So it's going to be a 2. 20 has a 2, but it doesn't have another 2 in common with the 30. So we're not going to include the other 2. And then they have a 5 that is in common. And then the 30 has a 3, but there is no factor of 3 in the 20. So their greatest common factor is going to be 2 times 5, which is 10. So if someone were to ask you what is the greatest common factor between the number 20 and the number 30, you would say its greatest common factor is 10. And what we're going to get into in this module is not just finding the greatest common factor between numbers, but actually finding the greatest common factor between algebraic expressions. So let's say we didn't just have a 20 and a 30. Let's say we had some variable parts. So let's say we had maybe an x squared, and then we had an x to the 4th. Then we just want to extend this idea and also look at the variable factors as well. So if you think about what's making up an x squared, they basically have an x and an x. So x times x is the x squared. And then what about the x to the 4th? You basically have 4 factors of x. And then we can continue doing what we were doing with the numbers. How many values of x do they have in common? So if we look at the first one, the 20x squared, there's 2 x's. And then if you look at the 30x to the 4th, they have 2 x's in common. So we could extend our greatest common factor to say that we have an x and an x in common. And then on the 30x to the 4th, you do have 2 more factors of x, but you don't have any more factors of x over here. So the greatest number of factors of x they have in common are 2 x's, so x times x. So our greatest common factor is going to be the 10. That was the common factors for the numbers. And then they have a x times x, so a x squared. So your greatest common factor between the 20x squared and the 30x to the 4th would be 10x squared. So they have a common factor of 10. And for the variables, they have a common factor of x to the second power, x squared. So in general, you're trying to find all the common numbers and common variables that the statements will have in common in terms of their factors. So let's go ahead and look at a few examples from IXL. So on this one, they want you to find the greatest common factor between a 3a squared and a 6. So if we think about the number parts first, we have a 3 and we have a 6. So the factors of 3 are just 3 and 1. So 3 times 1 is pretty much the only factorization for the number 3. And for the 6, you could break the 6 down into 2 times 3. And then the a squared, you're going to have a times a. And then on the 6, you have no variable parts. So what do they have in common? Looks like they have a 3 in common. And that's pretty much it. So it looks like their greatest common factor is going to be 3. That is the only factor that these two statements have in common. So they have a 3 in common. So in the answer box, you just want to go ahead and write in that they have a greatest common factor of 3. And looking at the next one, so we have a 3 and a 3x. So the 3 is 3 times 1. The 3x is 3 times x. So what do they have in common? They have a 3 in common. So the greatest common factor on this one is going to be a 3 again. And the next one, we have a 6y to the third. And the other one is a y to the third. So notice there's a comma here that's separating your two algebraic statements. So 6y to the third, comma, y to the third. So what are the factors of 6? 2 times 3. How would you factor out y to the third? That's y times y times y. And on the other monomial, we have y times y times y. So what do they have in common? They don't have any number parts in common, but they do have 3 y's in common. So it's going to be y to the third is your greatest common factor. So y to the third is your greatest common factor. This one you have an s and an 8. S times 1 is pretty much the only way to write that as multiplication. 8, we know that is a 2 and a 4. But the 4 could be broken down further, so the 4 could be 2 and 2. So if you want to break it all the way down into its prime factors, 8 would be 2 times 2 times 2. So they don't have anything in common as far as the variable s. They don't have anything in common as far as the numbers. So it looks like the only greatest common factor is technically a 1. There's always a factor of 1 in any number, because 1 times itself is always that value, or 1 multiplied by anything is whatever that value is. So they do technically have a common factor of 1. So your greatest common factor is 1. So you don't want to put 0 in there, or none. You want to say that they have a greatest common factor of 1 if they don't have any other factors in common. So every number always has a factor of 1 in common. In this one we have 6g. So 6g to the third and 3g to the second. So break down the number 6, that's 2 times 3. And break down the g to the third, that's going to be g times g times g. And this one, it's 3 times 1, if you wanted to multiply it against something. and then g times g. So what do they have in common? They have a 3 in common. And what about the g's? There's 2 g's and 2 g's. So the greatest number of g's that they have in common is 2 g's. There is another g in this one, but there is no other g in this one. So the greatest number of g's they have in common is 2 of them. So g times g, which is g to the second. And the next one, 6k to the second and 9k to the second. So the 6 can be broken down into 2 and 3. And k to the second is k times k. The 9 is a 3 times 3. And a k times k. So what do they have common? They have a 3 in common. And they have 2 k's in common. So k times k, which is k squared. And that should be it for the greatest common factor on that one. And this one has 3 different monomials, so same idea. We'll find the factors of all 3 and see which ones they have in common. So if we look at the 6t to the 4th is one of them, 12t to the 4th is the other one, and 15t to the 4th is that one. So the 6 is a 2 times 3. Make that a little cleaner. So the 6 is a 2 times 3. And then you have 4 t's. The 12, if we think about the number 12, we know 12 is 3 times 4. And then the 4 can be broken down further, so it's going to be 3 times 2 times 2. So a 12 is going to be 3 times 2 times 2. And then you have 4 t's again. And then the 15 is a 3 and a 5. 3 times 5 is 15, and then again you have 4 t's. And then we just want to scan through and see what they all have in common. So, do they all have a 2? This one has a 2, the first one has a 2, the second one has a 2, the third one does not have a 2, so they don't have a 2 in common between all 3. The next number is a 3. They have a 3 in common. So we can write down the 3. And then they have t to the 4th, t to the 4th, and t to the 4th all in common. So t to the 4th. The other numbers have other factors in them, but it's not common with all 3 of them. So that's just going to be 3t to the 4th. And this one's kind of the same question. It just isn't giving you something where they're just separating the monomials with a comma. They're actually putting them into a larger statement, a polynomial. And we're eventually going to be factoring polynomials so we can set them equal to 0 and solve. But right now we're just looking for that greatest common factor again. So we have a 5g to the 4th. And we're looking for the greatest common factor of 5g to the 4th and 10g to the 3rd. And you don't need to worry about the minus sign. We can worry about that later on in the course when we're trying to factor these so that we can solve equations. So what are the factors of 5? Just 5 and 1. And what are the factors of g to the 4th? G times g times g times g. And the 10 is a 2 times 5. And g to the 3rd is g times g times g. So what do they have in common? Looks like they have a 5 in common. And there's 3 G's here and 3 G's here. So they have 3 G's in common. So G times G times G, which is G to the third. And then again, there is a G on this one, but there is no G on this one. So the most G's they have in common are 3 G's. G times G times G, which is G to the third. And that can go into the answer box. And here's the next one, kind of same idea. The only difference is we now have 4 different terms. So we have this one, this one, this one, and this one. So if we look at the 18c to the fourth, so let's go 18c to the fourth is one of them. 6c to the second, 6c to the third, and 6c. So 18, how does that break down? So the number 18, we know that is a 2 and a 9. And then we know the 9 can break down further, so we have the 2, and then 9 is 3 times 3. So the 18 is going to be a 2, and a 3, and a 3, and then you have c to the fourth. So c, 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 and c. The 6 is going to be 2 times 3. And then c to the second is c times c. The next one, 6c to the third, that's going to be a 2 and a 3. And then c times c times c. And then the last one, 6c, the 6 is going to break down into 2 and 3. And then times c. So scanning through all 4, what do they have in common? Looks like they have a 2 that's common. What about the number 3? So we have a 3, a 3, a 3, and a 3. So all 4 of them have a 3. We do have another 3 here from the 18, but there are no more 3's in the other 3 monomials. So just a 2 and a 3 they have in common for the numbers. And then what about for the variables? So if we look at the variables, the largest number of variables is on the last one, which is just 1c. So this one has 1c. These ones have more c's, but again, we're looking for what's the largest number of factor c's that they have in common. So they just have 1c in common. So we could go ahead and say times c. And 2 times 3 should get you 6 times c. So it looks like 6c is their greatest common factor. And here's another one. So again, we're just looking for the greatest common factor. Technically, it's expressed as a polynomial with addition and subtraction between the terms, but for this lesson, we're just focusing on the different terms. So we have 16v to the fourth, 20v to the third, and a 2v to the second. So the number 16, 16, we know that's going to be a 4 and a 4. And the 4 and 4 can be each broken down into 2 times 2. So 2 times 2 times 2 times 2 makes up a 16. The u's, it's going to be u times u times u times u. The number 20 is a 4 and a 5. And 20 can be, 4 can be broken up into 2 and 2. So 2, 2, and 5 make up a 20. And then you have 3 v's, v times v times v. And the last one is 2 times 1, and then v times v. So what do they have common? They have, looks like a 2 in common. So the greatest number of 2's they have in common is 1, 2. And then how many v's do they have in common? Looks like v to the second. And I guess this is a typo. I guess those should all be v's, not u's. So those are v, 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 and v. So v to the second. So everything up here was a v. There are no u's in this problem. So that should be v to the second. So variable v. So v to the second. So they have a 2 in common, and then they have v times v. So again, not to confuse you, let's actually erase this and fix it. So these were originally supposed to be v's, not u's. So 2v to the second. And here's the last one. These are kind of a challenge problem. So they just get more complex, larger numbers, more variable parts to track. Once you get the hang of it, you might not even always write down the prime factorization of every number. You can just kind of look at it and see what they have in common. So for example, if we look at this first one, if we just look at the number parts and start thinking about the factors of 13, 39, 26, and 26. So 13, we know what 13 is, a 13 and a 1. So 13 times 1. 39, that should be 3 times 13. 26 is a 2 and a 13. And the other 26 would obviously be just a 2 and a 13. So between these different numbers, the 13, 39, and the 26, what do they essentially have in common? The common number between these three numbers, these 4 different terms, is going to be 13. So we could just go ahead and say they're going to have a 13 in common. And then if we move along to the variable parts, so there's a mixture of different variables here. So the first variable in the first term is q to the 9th. So q to the 9th. And then you have a q to the 7th in the next one, and a q to the 5th in the next one. And then the last one, there are no q's. So there is no q in the last one. So how many q's do all 4 terms have in common? They don't have any q's in common because the last one doesn't have a q in it. So there are no q's in common. And then if we look at the next type of variable, the r's, we have an r to the 7th, an r to the 4th, an r to the 6th, and an r to the 10th. So what's the largest quantity of r's that they have in common? So r to the 4th is the smallest number of r's. So for example, the first one has 7 r's, but r to the 4th doesn't have 7 r's. So r to the 4th is going to be the largest quantity of r's that they have in common. So we'll call that r to the 4th. So for the number parts, they have a 13 in common. For the q's, they didn't have any in common because the last one didn't have a q in it. So this one does not have a q, so there's no q's in common, but they did have 4 r's in common. So r times r times r times r. So 13r to the 4th.